Hello everyone, it's Jason from Skinny Research and Development. Today what we're going to do is look at an application of the 555 timer. We had a comment that came in from RC Canuck. So the question was, how would you go about building an LED that would blink twice, and then the circuit would switch to a second LED that would blink twice, and then that action would continue back and forth between the two LEDs. The application would be for like a navigation system on an airplane where you have lights blinking on it. So the moment the comment was left, I could not get that circuit out of my mind. I went throughout the week just kind of thinking of different ways to do it. My first thought was a microprocessor, but that's kind of cheating. The second thing was to use some sort of counter, but then I kind of thought a little bit more about it and realized that it could all be done just with a few 555 timers. That's what we're going to look at today. So the bag's all ready right here, so let's get going. While I'm in the middle of this, I should let you know that if you need to know a little bit about the 555 timer or are not quite sure how it works, I have a video. I will link it here. Just go take a look at that. It'll teach you how to use it, and then you'll be able to follow along with this video a lot better. So let us start with a timer. So when looking at this circuit, the one thing that's absolutely critical is timing. Okay, what we want to do is we want to be able to blink one LED for a certain amount of actually iterations, so 2 blinks, and then we want that to switch and blink another LED for 2 iterations. Now that wasn't so hard before. If you remember on the last video, we were able to make a light blink and then switch to another light blinking and then another, back and forth. That wasn't so tough. But in order to get a light to blink twice and then stop and then another light to blink twice, we're going to have to add a few more things. And timing is everything. So first thing to do is we're going to have kind of 2 stages of 555 timers. We're going to have a 555 timer in an initial stage, and we're going to have 2 more 555 timers later. What we want to do with this first 555 timer is to make this count really slow. What I mean by really slow? Well, I want it to go up and then down, and the time that it takes to do that, I want it to be roughly 3 seconds. So quick review on how we set the time on a 555 timer. There is we're going to say pin 8, pin 7, and pin 6 over here. Between 8 and 7 we have 1 resistor. We're going to call it RA. Between 7 and 6 we have a second resistor. Call it RB. Between pin 6 and ground we have a third component that's a capacitor, and call it C. And what we said were these 3 components control the timing for this 555 timer, and there was a formula that we used in order to accomplish this. So this particular formula gives us the frequency. If we take all of this, once we get the frequency, and we want to find out this time, you can plug into your calculator 1 over the frequency. You will get a time or a period. We want this t to be roughly equal to 3 seconds. So exactly what is this 3 seconds? Well, this 3 seconds is going to be the total amount of time it takes to blink both set of LEDs. Okay, so what I'm doing here is I'm giving 1.5 seconds for LED 1 to blink, and I'm giving 1.5 seconds for LED number 2 to blink. Okay, so I went through my bag of components. I found an RA of 10K. I found RB of 220K. I used a capacitor that was 10 microfarads, and ultimately I ended up with a time period of roughly 2.8 seconds. So it's not exactly 3 seconds, but you work with the components that you have, and these are the components that I had. That's going to be our total time for this waveform to go up and then down, or down and up, however you want to look at it. So that means on pin 3, I'm going to have this 3-second total waveform come out when I start the machine up, and this is just going to keep reoccurring every 3 seconds. Okay, so this is where it gets kind of cool, because this is where I kind of had problems at first trying to figure out how I was going to do this. What do I do with this output? Because remember what we said about the output. At one time, it's going to output, okay, this square wave, and when it goes high, it is sourcing voltage. It is sourcing current out of the timer into whatever circuit that I have. And then it goes low and it sinks current, which means it then provides a path to ground. The trick is coming up with some circuit on this side that will not only blink those LEDs like we want it to, but will also be able to tolerate the fact that this is going to go to ground sometimes, and then this is going to provide power sometimes. And so this is kind of what I came up with. What we're going to have is we're going to have 2 more 555 timers. We're going to start with the 555 timer on the bottom. We're going to use this output to control when this 555 timer turns on. Now, I showed you in a previous video where you could do this with an LED. You take a transistor, put it on this pin, you turn that transistor on, it acts like a gateway, and then it powers up LEDs. Well, in this case, what we're going to do is we're going to have that transistor power on this 555 timer. So this is what's going to happen whenever you have this output sourcing voltage. We're going to come out, we're going to go to a resistor, and have this at 10K. This resistor is then going to feed into an NPN transistor. The collector of this guy is going to be connected up to our power source. The emitter of this guy is going to be connected up to the power in on this 555 timer. So now every time this 555 timer here goes high, this 555 timer here is going to turn on. And what we can do is we then can set the RA, the RB, and the capacitance for this 555 timer. And what we can do is set these so that they are, say, twice as fast as what we have over here. So what I've done with this is I have RA equal to 10K. I have RB equal to 220K, just like last time. But this time I have the capacitance equal to 1 microfarad. So with these numbers, what I end up with is I end up with the fact that this thing is going to blink roughly 3 times per second, so at a rate of 3 hertz. So that means it's going to go on, off, roughly 3 times. However, it's not exact. A 555 timer is not super accurate, so you have to play with it. And so when I played with these values, what I found was I was able to get the light to actually blink 2 times in the time period of 1.5 seconds. It's not exactly 1.5 seconds. We said over here it's 2.8 seconds. So really, I've only got 1.4 seconds to do this. With these values, I'm able to blink the LED twice before that 1.4 seconds is up of on time. So you're going to have to play with these as well. You're going to have to mess with these values in order to get it to fit within a time scale that you want for your particular objective. But it's just a matter of changes. Now, if you want it to blink more than twice, then come back over here, extend this time out longer by increasing the size of the capacitor or increasing the size of the resistor, so that it takes more time for this capacitor to discharge or charge up when it's initially starting its timing sequence. So now we know that we can turn this 555 timer on for a certain amount of time, and then it's going to go off for a certain amount of time. So for roughly 1.4, 1.5 seconds, this is going to be on. Then this is going to kind of go into reverse, and it's going to be connected to ground. So this isn't going to power on at all. What do we do to be able to take advantage of that? So to do that, I want to mark this. Remember, this is an NPN transistor. It works when you apply some voltage, a certain amount of voltage. It's got to be above like 0.7 volts. But you apply some voltage here, it turns this on. I'm kind of simplifying this. This works like a gate and then allows this voltage to flow through and turn on this 555 timer. So we're going to do something different. One thing we're going to need though is we're also going to need a 10K resistor here. Now, some people might ask, why did I put this 10K resistor here? Remember, all this is for is to just kind of limit the current flowing into this transistor. So I'm going to have a 10K resistor here. I'm going to follow that up with a diode just a normal general purpose diode. And remember what a diode's good for. A diode is good to allow current to flow one direction, but not another direction. So when this becomes a source, the current is not going to be able to make its way the opposite direction on this diode. All right, you're pretty much going to be blocking anything from going this direction with this diode. So that's one purpose of the diode. It has a second purpose that we'll get to in a moment. Next, what we're going to do is we're going to connect this up to another transistor, but it's not going to be the same type of transistor that we've already used. In this case, we're going to use a PNP type transistor, and we're going to connect this up pin 8 on this 555 timer. So let's look at how this is going to work. Up here I have this PNP transistor. I have the emitter connected to power. The way the PNP transistor is working in this case is that we have a positive voltage here. Every time this base sees ground or a negative voltage, it allows the current to flow from the emitter through here, through the collector, and to the 555 timer and turn it on. When the 555 timer here starts to sink current, this will then be connected to ground. This base will then see the ground that it's looking for and allow current to flow through. One of the things I initially did was have this 10K resistor connected straight to this base, but it didn't quite work, and here's why. Remember that the output, when this goes high, is whatever the voltage is powering the 555 timer, so we're going to call that V, minus, I believe it was 1.7 volts, or roughly that. So the output voltage that comes out of here when it goes high is really V minus 1.7. This base sits, when it's not seeing ground, this base will sit at a voltage that is roughly the source voltage minus 0.7 volts. So if you leave this diode out, just enough current trickles through this to make these LEDs being blinked by this 555 timer just slightly dim. In other words, this 555 timer kind of barely turns on, and so you don't ever get a complete state where the lights blinking on this 555 timer go completely out. They want to kind of just go dim on you. So I hope you understand that. So if this is at 9 volts, then that means that this base is going to be at 8.3 volts. This output is going to be sitting at 7.3 volts. So you've got some current here that's being pulled in this direction. However, if I put this in line with it, then all of a sudden I get another 0.7 volts taken off. This diode drops 0.7 volts. So if we subtract out our 0.7 volts from this again, we're going to end up with 7.6 volts. And now we're getting closer and closer to that. There's still a little bit of current that can flow through, but this resistor kind of takes care of it, and it truly looks like this 555 timer doesn't cause the LEDs attached to it to blink. So this diode just kind of does double duty for you. It's because when this goes to 0 volts is the only time you want this 555 timer to turn on. The transistor stuff may be a bit confusing to you, but just remember, the NPN allows this 555 timer to turn on when this base receives voltage. This PNP transistor allows this 555 timer to turn on and blink lights whenever this base sees ground. Every time this goes high, this turns on, this stays off. Whenever this goes low, this turns on and this turns off. And then you're able to adjust the individual blinking LEDs with RA, RB, and C. You're able to adjust the overall timing scale with this 555 timer with RA, RB, and C as well. So hopefully this isn't blinding you too bad, but this is what it looks like when you breadboard it. My power source is just a simple 9-volt battery. There's 2 resistors right here. One is RA, one is RB, and then I have my capacitor here to set the timing for my first 555 timer. This branch, this direction, is what is turning on this 555 timer. This branch, this direction, is turning on this 555 timer. This one is controlled by the NPN transistor. This one is controlled by the PNP transistor. Now, the request was to be able to only blink one LED Instead, what I did is I just stacked 3 LEDs in there just to take full advantage of the power. And then if you'll notice, I also have a transistor here, just like one of the last videos, in order to turn on and off this stack of LEDs. These are NPN transistors. If you want to learn about that, I'll have a link for that video as well, probably over in this range somewhere. Remember, in order to, if you just want to do one LED, all you have to do is throw one LED in there and then calculate what size resistor you need to take care of that LED so it doesn't pull too much current. And then all I've got that is in line with an NPN transistor, so that every time this guy here goes high, it turns this NPN on and allows current to flow from the LEDs to ground, thus turning them on. Here's a really quick close-up in case you wanted to be able to kind of see what I've done, but I think that's about it. So I'd like to thank you guys for your comments and questions. Thank you for this circuit. It was really interesting to be able to work this out and figure out how it works and if it could work with 555 timers. I really enjoyed putting it together. Some of you have suggested other types of things that you'd like to see done. I'm considering doing videos about those as well. For some of the next videos that I make, I'm looking at maybe doing a video about transistors. That would be further down the line. A lot of stuff on the internet seems to be very engineering, and it's not something that you can really use. It's really good for math, but I'd like to see a pretty good video about it. So I think I might put that together. Also, I'd like to thank everyone for all your subscriptions, all the likes on all the videos. It's been very humbling. If you have any suggestions or comments or any ideas on circuits you'd like to see, please leave it down in the comments. But that's all I've got for you now, and thanks for watching this video. See you next time. Bye.